Hello and welcome to the Bioassay Research Database. In this video and in a subsequent video, I'm going to demonstrate some of the functionality that allows data mining through the web interface or the web client of the Bioassay Research Database, or BARD. In a previous video, my colleague Jason Rose covered some of the basics about search and using the search box, and also about data entry through the Catalog of Assay Protocols, or CAP. In this video, I'm going to start looking at some of the mining tools, and in particular, some of the ways to look at historical data mining. The next video will cover some of the more hypothesis generation mining tools. So one functionality of BARD is as a repository to quickly look up and understand the assay data that went into some of the projects, in particular the molecular libraries projects, but also any project that has a series of assays used to identify and refine the selectivity of compounds, for example, for probe development. So one thing you might want to do, for example, so this is the BARD homepage, is say that you see a molecular libraries probe in the literature identified by their ML numbers. And what you can do is go to BARD and search by an ML number. So for example, I will search ML162. And that brings up a few things up in the tabs up here, which Jason covered what these mean. But you can see there's a compound tab where ML162 itself comes up. There's the structure of it. And this other compound comes up because it's related to ML162. It actually was a probe that was found in a project where ML162 was found, and there were two probes found. So you get both the probes for that project. So if you want to know more about these probes, you can go look at the project page itself. And there's a link directly there to the probe reports for both ML162 and ML210 down here. And so you can click on that, and it will take you directly to the molecular libraries bookshelf, and you can read the probe report and understand how this probe was developed. But if you don't want to read all that text, you can also visualize the data in BARD. And so the way to do that is you can use your query cart to basically create a matrix, and that's the core visualization of BARD, is a matrix of compounds across bioassays. So the way we do that is there's something called the query cart that Jason covered, and you can save items to the cart for analysis. So I'm going to save ML162, and I'll do ML210 as well, since it's there. And you can see now I have two items in my query cart up here. So those are your compound inputs. Now you need to have bioassay input. And so you could go through, if you go down the project page here, you can see that there's an organization of all of the assays that went into the project, and Jason covered how that is constructed. But instead of having to add each of these individually, if you want to add everything that's in an entire project at once, you can just add the entire project to the cart. Now what this visualization will give you then is all of those assay definitions or assay protocols, and the results for those two compounds, ML162 and ML210, or the systematic name of ML210 shows up here, and you can visualize by molecular spreadsheet. And what you'll see, that this gives you a pretty quick view into how the probes were developed and what their activities were. And so across on the vertical axis here, we have the two compounds. And across the top here, we have the assay definitions and the individual experiments. So remember, an assay definition is an abstract thing that doesn't hold any data itself, but experiments all use the same assay definition and relate back to the assay definition but contain the actual data. And so what you can see here is that in various experiments, you can see that ML162 was tested and ML210 was tested, so you can compare the potency in a particular assay definition, and you can compare that to the various assays that were used to discover that probe. Another one over there. All right, and you can also do things like transpose this visualization if you want, but we won't do that. So if you want to understand, well, what were these experiments, what was the purpose of them, you can actually go back and look at that, that tree. So I'm actually going to open a separate tab here and go back to my project so I can see that tree again. And what I'm going to do is go down to the tree, and I'm going to find one of these experiments. So, okay, ML162 was active in EID 1115. So let's find 1115 on the tree here. Oh, here it is right here. And you can see that it was a round of SAR, and it's a confirmation of dose. And the text here reads, alternative assay readout. So it's telling you that it's something where the compound should have been active. And you can go through and do similar things with the counter screens, etc. So that's a way to pretty rapidly understand the selectivity by looking at things that are labeled counter screen versus primary screen or artifact screen, that sort of thing. There's a range of control vocabulary terms for the different assay stages, whether they're confirmatory screens or counter screens or orthogonal screens. So that's sort of the historical view of a project. And what we can also do is look at the primary screen. Now here's something where BARD was not a focus, a piece of data that was not a focus of BARD, because other systems basically do just as well and or have good systems for viewing HTS data. So what you can see here is that, you may have missed that, I clicked on that one because it was labeled as the primary screen. And so you can see here, I go down to the experiment where I can see the results. So some annotations on the experiment, but what you can see down here is we do display a histogram summarizing the results for the HTS. But keep in mind, as I said, the core visualization of BARD was looking at compounds across assays, not looking at entire assays themselves. If you want to see that, you can, it does say you can view all results for this experiment. You're going to see a lot of things. Right now it's restricted, again, using the faceting tool over here. It's restricted to active compounds, of which there are 516. So there's at 10 per page, there's 52 pages. So you probably don't want to scroll through that. And you can actually, if you click that off, it'll show all the compounds because you've taken off the active compound filter. And now you have 303,000 since 30,329 pages at 10 per page. So that's not something you'd want to visualize here. It's really just, this is meant to be a summary of the results. Where the HTS results would come in is when you are looking at the activity of a compound. You want to see, say, its historical results. You can pull up all the HTS data for particular compounds. If you do want to get the full data set for an HTS, there are two ways to do it. One is to go back to the historical system from which we imported, PubChem, and there's a link on all the assay pages and experiment pages where we imported from PubChem. And so now we're back here, and you can use the PubChem tools to get that. And the other thing is that the HTS data is available programmatically through the API, or the application programming interface. And so it is possible to write tools that will query the database directly, and you can pull all 303,000 data points from the database into a tool of your design. So again, that's sort of an expert function, but the information is there in the database. It's just the web client view did not emphasize the visualization of HTS data because, as I said, there are other tools available out there for that. So that's the demonstration of the sort of historical data mining aspect of the web query client. And in my next video, I will go into more of the sort of artifact and data mining, artifact discovery, data mining, and hypothesis generation tools that are available in the web client. So thank you for watching.